The most explosive hurricane strengthening ever measured on this planet did not happen near Florida. It did not happen near Texas. It happened off a stretch of Mexican coastline that nobody was watching, against a city of nearly 1 million people who had less than 12 hours of real warning. Otis, a storm that satellites clocked as a disorganized tropical system on a Sunday, was a Category 5 monster by Tuesday night, and the terrifying part is not how strong it got, it is how fast. In one 24-hour window, its winds jumped by 115 miles per hour. No guessing, no dramatizing, just the facts, the science, and the real stakes. Today we are going to break down exactly how a storm can go from harmless to catastrophic in less time than it takes to drive across a single state, why the forecasting models missed it completely, and whether the same setup is now sitting in the waters closer to the United States than anyone would like. Drop a comment right now. Have you ever personally lived through a storm that intensified faster than anyone expected? Tell me where you were and what it felt like when the forecast changed under your feet. If you want to be the first to know every time something major happens, subscribe. It is completely free. A thumbs up also helps enormously. Let us go for 5,000 likes on this one so the algorithm actually shows it to people who need to see it. Now, let us get into it. On the morning of October the 22nd, 2023, a cluster of thunderstorms a few hundred miles south of Acapulco, Mexico, was upgraded to Tropical Storm Otis. At that point, it looked unremarkable. Forecasters expected a modest storm, maybe a Category 1 at worst, staying far enough offshore to spare the coast a direct hit. That forecast held for almost 2 full days. Then, on the evening of October the 24th, something happened that meteorologists still study today. In a single 6-hour stretch, Otis's maximum sustained winds climbed from around 65 miles per hour to more than 120. Over the following 18 hours, they kept climbing. By 10 o'clock that night, the National Hurricane Center's own forecast discussion used 4 words rarely seen in an official government bulletin: a nightmare scenario is unfolding. Otis had explosively intensified by 95 knots, roughly 110 miles per hour, in 24 hours. To put that in context, meteorologists only consider a storm to have undergone rapid intensification if it gains 35 miles per hour in a day. Otis gained more than 3 times that. In modern satellite-era record-keeping, only one storm had ever intensified faster in that basin: Hurricane Patricia, back in 2015. By the early hours of October the 25th, Otis made landfall just west of Acapulco as a full Category 5 hurricane, sustained winds of 165 miles per hour, gusts recorded at over 200. A weather station inside Acapulco Bay measured a wind gust of 178 knots, more than 200 miles per hour, before the instrument itself was destroyed. The storm's central pressure had dropped to 922 millibars, among the lowest ever measured at landfall anywhere in the eastern Pacific. That changed fast, and there was almost no time for anyone below it to change with it. Acapulco, a city of nearly 1 million residents plus tourists, had been told less than half a day earlier to expect a tropical storm. Instead, they got the strongest hurricane ever recorded to strike Mexico's Pacific coast. The destruction that followed was staggering by any measure. More than 50 confirmed deaths, more than 30 people still listed as missing in the weeks after. Roughly 51,000 homes destroyed or severely damaged. An estimated 5,000 homes alone were lost to flash flooding and mudslides in the hillside neighborhoods outside the tourist zone, the areas with the least infrastructure to absorb the blow. Total damage estimates ran between $12 and $16 billion, making Otis the costliest hurricane in Mexican history, a title it earned in a matter of hours, not years. Communication lines went down almost immediately, which meant that for the first day, the outside world had almost no real information about what was happening on the ground. Cell towers, power lines, water treatment infrastructure, all of it went down together, in a city that had never been built to withstand anything like this. Tens of thousands of families lost power and running water simultaneously. The government of the state of Guerrero eventually mobilized thousands of soldiers just to begin distributing food and water to a population that had, in the space of one night, been cut off from the rest of the country. In the hours before landfall, hotel workers and residents along Acapulco Bay were still receiving the older, calmer forecast, the one that called for a tropical storm making a glancing approach. Some businesses had done nothing more than the routine storm prep they would do for any seasonal rain event. By the time official warnings caught up to what radar and reconnaissance aircraft were actually seeing, the storm was already a matter of hours from the coast, not days. Emergency broadcasts that finally matched the true threat level went out only a handful of hours before the eye wall crossed the shoreline, and for a coastal population of nearly 1 million people, a handful of hours is nowhere near enough time to move vulnerable residents, secure hillside homes built from lighter materials, or stockpile supplies beyond what a household already had on hand for an ordinary week. And here is the detail that keeps meteorologists awake at night. Otis was not even an anomaly on its own. Just 2 weeks earlier, Hurricane Lydia had made landfall on the same stretch of Mexican coastline as a Category 4, after intensifying by 65 miles per hour in the 24 hours before landfall. Two rapid intensifiers hitting nearly the same coastline in the same month. Mexico's Pacific coast typically sees around 4 hurricane landfalls every 3 years. It saw 3 landfalls in a single October. If you follow hurricane news at all, the name Otis probably already rings a bell, and there is a reason meteorologists keep bringing it back up. It became, almost overnight, the reference point for a phenomenon scientists had been warning about for years, but had never watched happen this fast, this close to a major population center, this far outside what any operational forecast model predicted. To put the forecasting failure in context, the official National Hurricane Center forecast, issued less than 24 hours before landfall, called for Otis to remain a tropical storm or a weak Category 1. Instead, it was a Category 5 knocking on Acapulco's door within hours of that forecast being issued. This is not a case of a government agency being careless. The National Hurricane Center has one of the best track records of any forecasting institution on Earth. Otis exposed something scientists generally do not like to admit out loud. Current forecast models are far better at predicting where a storm will go than how violently it can grow, especially in the final day before landfall. So what actually happened inside that storm? To put it in context, a hurricane is essentially a heat engine. It pulls warm, moist air up off the ocean surface, and the warmer that surface water is, the more fuel the engine has to burn. In the days before Otis exploded, ocean temperatures in that stretch of the eastern Pacific were running about 1.8 degrees Fahrenheit above the 1991 to 2020 average for that time of year, a combination of a seasonal El Niño pattern layered on top of a long-term warming ocean. Warmer water alone does not guarantee an explosive storm. Otis needed a second ingredient, and it got one, a powerful jet streak, a fast-moving ribbon of upper atmosphere wind, positioned almost perfectly above the storm. That jet streak created what meteorologists call upper-level divergence, essentially a vacuum effect, pulling air out of the top of the storm faster than it could be replaced. When you pull air out of the top of a hurricane that fast, the pressure at its center collapses, and a collapsing central pressure is the single biggest driver of rapid wind acceleration. Warm fuel below, a vacuum above. Otis had both at the same moment directly over the same patch of ocean, and the result was a storm that broke the fastest intensification record in that basin's satellite-era history. There is a second layer to the mechanism worth understanding, because it explains why forecasters were caught so off guard. Otis was also a physically compact storm, small in diameter compared to sprawling giants like a Hurricane Sandy. Smaller storms can spin up faster than large ones, the same way a compact figure skater spins faster than one with arms outstretched, because a tighter system concentrates its energy over a smaller area. Combine a compact core, a vacuum-like jet streak overhead, and abnormally warm water below, and you get a storm that behaves less like the gradual, days-long buildup most forecast models are trained on, and more like a system that seems to defy its own forecast in real time. Reconnaissance aircraft flying into Otis on the afternoon before landfall recorded conditions that, hours later, no longer matched what they had just measured, because the storm kept strengthening even as the data was being analyzed on the ground. Here is why this matters far beyond one Mexican coastline. Scientists have published multiple peer-reviewed studies over the past several years documenting a measurable increase in the rate at which tropical storms intensify, both in the eastern Pacific and in the Atlantic basin, that directly threatens the United States. There is currently no scientific evidence that every future storm will behave like Otis. Rapid intensification is still relatively rare, and most storms follow a far more gradual, more forecastable curve, but the ocean conditions that allowed Otis to happen, unusually warm surface water paired with favorable upper-level wind patterns, are not unique to the Mexican Pacific coast. Those same ingredients regularly show up in the Gulf of Mexico and the western Atlantic, the exact waters that sit off the coasts of Texas, Louisiana, Florida, and the Carolinas. Consider the timeline side by side with a storm most Americans already remember. Hurricane Ian, which struck southwest Florida in 2022, also intensified quickly, gaining roughly 55 miles per hour in the day before landfall. That is a serious rapid intensification event by any definition. But Ian's broader track had still been flagged by forecasters nearly a week out, giving Florida's emergency management agencies days, not hours, to stage the response. Ian caused well over 100 fatalities, a tragedy by any measure, but a number that reflects a storm whose overall danger, if not its final hours of strengthening, had been visible on the map for the better part of a week. Otis had no such runway. The entire event, from an unremarkable tropical storm to the strongest hurricane ever recorded on that coastline, played out inside of about 72 hours, with the truly violent phase compressed into less than one full day. That is the number that should stick with you. 72 hours from formation to catastrophe, and less than 12 of those hours contained any forecast that matched the storm's true danger. The difference between what happened in Acapulco and what could happen on a U.S. coastline is not luck. It is preparation, timing, and the accident of geography. Acapulco had a well-resourced emergency system by Mexican standards, and it still could not physically move 1 million people, secure a coastline, and harden critical infrastructure in the roughly 12 hours between tropical storm and Category 5 monster at your door. Compare that to a well-worn system. When hurricanes give forecasters 3, 4, 5 days of advance notice, coastal counties in the United States can stage evacuations, pre-position emergency crews, and get vulnerable residents out ahead of landfall. And death tolls, while still tragic, are typically measured in single or low double digits rather than in the dozens or hundreds. These are not just meteorological events, they are human experiences, and the entire difference between a manageable disaster and a catastrophic one often comes down to how many hours of true warning the people in harm's way actually get. Otis proved that even a well-monitored coastline, watched by satellites in real time, can still lose almost all of that warning window if the storm intensifies fast enough. There was no meaningful warning for the people in the hillside neighborhoods above Acapulco Bay, no alert that matched the true scale of what was coming, no time to board windows or stockpile water beyond what a family already had in the house. Millions of people up and down storm-exposed coastlines live with a version of that same vulnerability today, not because agencies are not trying, but because the physics of rapid intensification is currently outrunning the lead time our forecasting tools can reliably provide. So what are scientists actually watching next? Ocean heat content across the Gulf of Mexico and the western Atlantic has been trending upward for years, and researchers monitor it constantly precisely because it is one of the 2 core ingredients Otis needed. Keep an eye on ocean temperature anomaly maps every hurricane season when large patches of the Gulf or the Caribbean run more than a degree or 2 above seasonal average, that is fuel sitting in the tank. The second ingredient, favorable upper-level wind patterns that create that vacuum effect, is far harder to predict more than a few days out, which is exactly why Otis-style intensification remains so difficult to forecast even now. Meteorologists have also been tracking a broader pattern. Studies looking at decades of Atlantic storm data have found that the rate of rapid intensification events has been climbing, not because more storms form, but because a larger share of the storms that do form are hitting that 35 miles per hour in 24 hours threshold than they used to. The Gulf of Mexico is a particular focus of concern among storm scientists, and not because of speculation. It is a comparatively shallow, warm body of water that heats up fast and holds that heat through much of hurricane season, giving any storm that crosses it a concentrated dose of fuel with very little distance to travel before reaching land. A storm that undergoes Otis-level intensification a few hundred miles from a Mexican coastline is alarming. A storm that did the same thing in the middle of the Gulf, closer to the Texas or Louisiana coast, would leave emergency management agencies with a fraction of the response window they currently plan around. This is not a prediction that it will happen this season or next season. It is the reason agencies like NOAA and the National Hurricane Center have spent the past several years investing heavily in next-generation modeling specifically aimed at closing the rapid intensification forecasting gap, because the current tools, while excellent at tracking a storm's path, still struggle with predicting explosive strengthening in the final 24 to 48 hours before landfall. Researchers at agencies including NOAA have also started deploying ocean glider networks and expanded satellite passes specifically over the Gulf and Caribbean during peak season, gathering the kind of real-time subsurface ocean heat data that simply did not exist in the density needed to catch an Otis-style spike a decade ago. Part of what makes this genuinely hard is that the ingredient driving the intensification, that upper-level jet streak creating the vacuum effect, often only becomes visible to forecasters 12 to 24 hours before it matters, which is precisely the same narrow window that cost Acapulco nearly all of its warning time. Scientists are not just watching ocean temperature anymore, they are racing to build models that can catch that upper atmosphere signal early enough to matter, and every hurricane season is treated as another real-world test of whether that gap has meaningfully closed. Is a monster storm currently strengthening somewhere on Earth with a real chance of catching a U.S. coastline off guard the way Otis caught Acapulco? Scientists cannot accurately predict that months or even weeks in advance, and there is currently no scientific evidence pointing to an imminent repeat scenario on American shores. The supervolcano scale panic some corners of the internet like to attach to every hurricane season is not supported by the data, but here is the part that should not be dismissed either. The ocean conditions that make an Otis-style event possible are not rare anymore, and they are not confined to one coastline. They exist, in some form, in the Gulf and the Western Atlantic during a meaningful stretch of every hurricane season now, which means the real danger isn't some singular monster storm already named and already tracked. It's the still unnamed disturbance sitting quietly off a warm coastline right now, the one nobody is watching yet, that has the exact same ingredients Otis had. That callback is the whole reason emergency planners keep repeating the same advice every single year, regardless of how quiet the season looks on paper. Prepare for the season you have, not the forecast you were given, because the forecast can change faster than anyone expects it to. If you live anywhere along the Gulf Coast or the Atlantic seaboard, here is what actually matters from everything you just heard. The lead time you are promised by a 5-day forecast cone is not a guarantee. Otis proved that a storm sitting well within a normal forecast track can still deliver almost no real warning if it intensifies explosively in its final hours. Have your evacuation plan ready before a storm is even named, not after, because by the time a storm looks dangerous on the news, the window to act safely may already be closing faster than the graphic on your screen suggests. Drop a comment and let me know. Are you in a hurricane-exposed region, and does your household actually have a plan ready before the season starts, or are you planning to figure it out when the moment comes? Let us go for 5,000 likes on this one so more people see it before their own season starts. Let us go. See you in the next one.